Morning exercise science, chapter 12 intro today. Everything's looking good relative to your work that you've been doing for me previously. I have not checked your assessments yet for chapter 11. I'm going to do that at some point today. It's actually Sunday. I'm going to be posting this for tomorrow as we kick off chapter 12. Chapter 12 is a pretty important chapter. We're going to be dealing with the heart and the cardiovascular system in its entirety. So to start this chapter out, probably the best way to start, or best place to start, is with the heart itself. What does the heart do? I guess that's a question you need to ask yourself. It's a pretty simple answer. It pumps blood. Pumping blood is obviously important because in order to get the nutrients and the waste removed, nutrients delivered and the waste removed from the body, we have to have a delivery system. The blood is what carries everything. The vessels attached to the heart take them to the places they need to go, and the heart provides the muscle. No pun intended. The heart is a large muscle, a specific type of muscle called cardiac muscle, which we learned about back in chapter 4. Just like when we talk about other organs and organ systems, levels of organization always comes into play. There are 3 basic tissue layers that make up the heart. And I will write those on the board right now. I'm going to do the best I can. I'll repeat this if I have to because I don't know how this is going to pick up when I say it with my back turned to the camera. So your 3 basic tissue layers in the heart, starting on the inside, are the endocardium, the second layer is the myocardium, and the final or outside or outermost layer is the pericardium. We've been talking to you all year about understanding and application of medical terminology, understanding how to break down base words, prefixes, suffixes to understand what a word means. Endocardium, I think, is fairly self-explanatory. Endo means inside. This is the glassy kind of, it's a flexible tissue. If you touch it with your hands, and if we were in class right now, I'd have a heart dissected for you so you could see it. But the inner layer is very smooth. And obviously the whole point of that is to avoid the formation of clots. Anytime you disrupt the pattern of blood flow, your body can initiate the clot process, which you don't want to form clots, as we discussed last chapter, in healthy vessels. So the endocardium is very smooth. Unfortunately, there are a lot of bacteria that enjoy, especially streptococcus, strep, that like to use this as a food source. So a lot of times when we have infections in our mouth, specifically in our lower jaws, they'll treat us with antibiotics, and it's not as much to clear that up, but it's to prevent that bacteria to spread down because, believe it or not, your jaw cavity is connected with your thoracic cavity into the heart. Before antibiotics, people that would have strep infections would be at risk of developing a condition called rheumatic fever, which is a secondary strep infection that could spread to the connective tissue of the joints, the heart, endocardium specifically, and weaken the heart. People that would have rheumatic fever untreated would be very susceptible to myocardial infarctions, heart attacks, cardiac arrest, early stages in their lives, sometimes as young as in their 20s and 30s. Just a little aside, so that's the endocardium. Its job, again, is to promote a smooth flow of blood as it travels to the inside of the heart. The middle layer is the myocardium. Myo, again, meaning muscle, which is a prefix you should be very familiar with. The myocardial layer is the pumping, physical, structural layer of the heart. It's the thickest layer of the heart, and it provides the force for the contractions that are needed to pump blood around the body. And finally, on the outside layer of the heart is a 2-layered membrane called the pericardium, which has some fluid in the middle of it. This is for insulation, protection of the heart itself. There's a little bit of fat on the outside of this as well, again, for more insulation. But those are your 3 basic tissue layers that make up the heart: endocardium, myocardium, and peri. Again, peri meaning perimeter on the outside. The next thing that we're going to do, and I'm going to draw this on the board behind me as I do it, is diagram the heart. Now what I've done, if you look at an actual schematic view of the heart, either online or in a textbook, you're going to see that the right and the left sides of the heart are pretty much intermingled as far as the way they're separate, but they kind of lay on top of each other. So what I'm going to do in this diagram, the one that I provided for you online in your notes, take a peek at that please. I don't know if you have the ability to print it out, but at least you can look at it digitally, is I've kind of flattened it out for you. I've separated the right and the left sides, so it's very easy to see the vessels that come in and the vessels that leave. And what I'll do as I draw this up on the board, I'm looking at my timer right now. I don't know if I'm going to take this amount of time to do this, or maybe just have this on the board behind me the next time I record. So again, instead of doing that, I've changed pace here as we're right in the middle of the video. Let's just discuss what the right and the left sides of the heart are for. First of all, the heart has 4 chambers. There are 2 atria, which are superior, and then there are 2 ventricles. The atria's job is to collect blood, either from the body or from the lungs, and I'll explain that further in a moment. The ventricles are the pumping inferior chambers. They're the ones in the bottom of the heart. These are the ones that provide the force to move the blood out of the heart, either sending it to the tissue around the lungs or to the body itself. The right side of the heart, and this is important to remember, this is something that I focus on in all my classes, to understand that the right and left side of the heart are divided, and as much as they're working in synchrony, they have separate functions. The right side of the heart's job is to collect blood from the body that has low oxygen and high carbon dioxide. So this is blood that's come back from the tissues, it's dropped off its oxygen, it's picked up the waste gas CO2, and now it's going to be collected in the right atria. The right atria will send that blood to the right ventricle, and then the right ventricle will send that blood to the tissue around the lungs for a process called gas exchange. In gas exchange by diffusion, what will happen is that the CO2 that's in the bloodstream will pass through the walls of the capillaries, surround the lung tissue, into the lung area itself, and you'll exhale it. At the same time that's happening, like 2 people passing on a sidewalk, oxygen will be diffusing out of the lung space into those same capillaries, and those capillaries will carry that blood through a system of larger vessels, which we'll discuss next time I talk to you, back to the left side of the heart. So now what the left side of the heart does is it collects that high oxygen, low CO2 blood, and in the atria, the left atria, left ventricle is going to pump that blood to the entire body. The entire body is going to get this oxygen-rich blood, whether it's the tip of your nose, one of your toes on your foot, the skin, muscle, all the tissues in the body rely on the left side of the heart to supply it with high oxygen blood, including the heart itself. And we'll discuss that also. So again, sorry for the change of plans on the fly, but as I was thinking and looking at my timer, I'll have this drawing up on the board the next time that I record for you, and we can discuss the pattern of blood flow through the heart specifically and all the structures involved. Have a good day.